All right, section 5.7, using congruent triangles, and 5.8, coordinate geometry. We're going to look mostly into coordinate geometry right now because we talked about congruent triangles before already, but we will be practicing in class. So for our learning target, I can classify triangles on the coordinate plane by its angles and by its sides. So these are the two things you're going to need here to classify triangles by angles and sides. You need to be able to use the distance formula, right, or Pythagorean theorem if you're comfortable with that. And also you need to be able to find the slope of lines, right? So you can identify perpendicular lines. So perpendicular lines have negative reciprocal slope, okay? So what is negative reciprocal? Well, you take the opposite sign, right? And then you flip the fraction. So if I'm talking about one line has a slope of 4 over 5, then if I need to find the perpendicular line to that line, I just have to use the reciprocal, negative reciprocal of that, which is negative 5 over 4. Okay. So first here, I'm going to do the distance formula with you guys, and then you're going to do the other one, the ones that are highlighted in pink, okay? But remember, you're just following the distance formula. You have that on your reference sheet, so you don't need to memorize it, okay? So here I'm going to do negative 1 minus 7 squared plus negative 4 minus 3 squared. Now I'm going through it kind of fast because you should be able to do this already. If you don't, you need to practice, okay? So this is going to be negative 1, negative 7 is going to be a negative 8 squared plus negative 4 minus 3 is going to give me a negative 7 squared. So now I get 8 squared, negative 8 squared is 64, and negative 7 squared is 49. 64 plus 49 gives me 113. 113. Okay, so that means the distance between just these 2 points is square root of 113. This one, I'm going to ask you to do it so you can practice one there. Here, I'm asking what is the negative reciprocal of each number so you can practice a little bit. But here, if I have 1 over 2, the opposite reciprocal, so opposite would be the opposite sign. So this is positive, so it's going to be negative. And I just flip the numbers, okay? 2 over 1. So that's going to be negative 2. You can just disregard the 1. The opposite reciprocal of 1, let's think about it. This is 1 over 1, right? So if I want to do the opposite reciprocal, the sign, I'm going to put a negative. And it's still, if I flip this, I get still 1 over 1. So it's just negative 1. Okay? Do number 2 and number 4. We'll take a look at that in class. Okay, this is mostly review. And here, let's take a look at classifying the triangles. So we have 3 types of triangles by sides. We have scalene, which we haven't talked about it, but you might be familiar with. That means all 3 sides of the triangle have different lengths. So it could look something like this. 1 tick mark here, 2 tick marks here, 3 here. So I know all 3 have different lengths. Isosceles triangle, 2 of the 3 sides of the triangle have the same length. So we talked about this in the previous lesson in this chapter. So I have the 2 legs are the same, the base angles are the same, and the vertex angle is different. Equilateral triangle, all 3 sides of the triangle have same length. Okay, we also talked about equilateral, so they're all the same, and the angles are also all the same. So it's equiangular as well. Now, in order for us to classify any triangle by its sides, right, on the coordinate plane, we have to use the distance formula so that we can compare the length of each side, right, and then identify if it's scalene, isosceles, or equilateral, okay? To classify by angles, right, the right triangle has 1 right angle. Acute triangle have all acute angles. And an obtuse triangle, one of the angles is going to be obtuse. Okay? Now, in order for us to classify a right triangle, right, we have to use the slope, right? Opposite reciprocal slope. Okay? Yes, because to identify the other angles, you can just visually see if it's acute or if it's obtuse. Okay? All right, so let's take a look at this first example. It said the coordinates of the vertices of triangle ABC are such and such right here. Show that triangle ABC is scalene. So I've already graphed it out, but to show that it's scalene, right, I have to show that AC is different than CB and is different than AB. Right? So if I show that three sides lengths are different, then that is going to be scaling. So I have to use the distance formula, right? But let's do this though. AC is a horizontal line. So here we don't have to use the distance formula. We just count the units. 1, 2, 3, 4, 5, 6, 7. So AC is 7 units. Okay. AB, we're going to have to use the distance formula, or for the honor students, if you're able to just use the Pythagorean theorem here, right? This has a length of 1, 2, 3, 4, and this has a length of 1, 2, 3, 4, 5. So 5 squared plus 4 squared, and then take the square root of that, okay? So let's see here, AB. So here I have negative 5. Sorry, let's start with x2. So negative 1 minus a negative 5 squared plus negative 2 minus 3 squared. So here this becomes a plus. So negative 1 plus 5 gives me 4 squared, plus negative 2 minus 3 gives me a negative 5 squared. So that's 16 plus 25, which equals 41. So square root of 41. Don't forget to use the square root, okay, at the end. So this is the length of AB. So they are already different. AB and AC are different. So now we have to find the length of CB. So CB equals, let's see here, 2 minus a negative 1, right? We start with the x squared, plus 3 minus a negative 2 squared. So here, this becomes a plus, this becomes a plus. I'm going to go underneath here. So 2 plus 1 is 3, so this is 3 squared, plus 3 plus 2 is 5, so 5 squared. So I get square root of 9 plus 25. Which gives me square root of 34. Sorry, I don't know what happened there. I think I got a phone call and then the screen went away. So CB is square root of 34. Okay, so AC is different than AB, which is different than CB. So triangle ABC is scalene. Okay, so that's how we show that the triangle is scalene. Okay, this one I'm going to ask you to do it. Okay, so you're going to graph it out. once you graph it out, you'll be able to see, okay, we're trying to show that it's isosceles, right? So you're going to be able to see the base, right, and the two legs. So then you have to make sure that the two legs have the same length by using the distance formula, okay? Let's do this one together. Okay, I already graphed it out. We're trying to show that this is a right triangle. Okay, looking at it, okay, I can see that this is a right triangle because this segment right here, this side PQ, is a horizontal line. RQ is vertical. So I know that vertical with horizontal makes a 90-degree angle. They're perpendicular. Okay, so we just have to kind of like explain that. Okay, so PQ is horizontal. RQ is vertical. Okay, so horizontal and vertical lines are perpendicular. So triangle PQR is a right triangle. Okay, that's basically it. Here we go. This one, we want to classify the triangle by side and by angle. Okay, so remember, to classify by side is distance formula. By angle, okay, if we suspect that it's a right triangle, we have to use the slope. Okay, slope of the sides. All right, so here we're lucky that this one, I have a vertical side and a horizontal side, right? Horizontal and vertical. So these we can just count, okay? But first, let's go ahead and say that triangle HIJ is a right triangle, okay? Since JH and HI are perpendicular. Okay, and it's the same thing, right? Horizontal and vertical lines. Horizontal and vertical. Okay, so this we already classified by the angle. By the side, we have to compare the length of each side. So again, we are lucky that this is squared, kind of squared with the coordinate plane. So JH, we just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 units. HI, 1, 2, 3, 4, 5. 5 units. And then IJ, we have to use the distance formula. So here's IJ, 0 minus 5 squared plus 10 minus a negative 2 squared. So 0 minus 5 gives me a negative 5 squared plus 10, this becomes a plus, 10 plus 2 is 12 squared. So I have 25 plus 144, which gives me square root of 169, which equals 13. So IJ is 13 units. Okay, so the triangle, so all sides, I ran out of space here, but I'm going to write it over here. All sides are different. So triangle HIJ is scalene. Okay, next two problems you're gonna do on your own. This one, again, you're classifying by side and by angle. Graph it out, right? Have a little intuition of what it is, and then show. And then this one, you're also doing on your own. Okay, I strongly recommend you plot, graph it out so that you can have an idea.